यहाँ पर आपको एजुकेशन, एक्सप्लेनेशन, टॉप 10 क्वेश्चंस, इंपॉर्टेंट क्वेश्चंस और एग्जाम्स के मुताबिक न्यू अपडेट्स मिलती रहेंगी।
My dear students, welcome back to our channel. In this video, I will be explaining the MBA third semester subject DBMS Database Management System as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Long questions will cover short questions. Unit 3 first important long question is Evaluation of relational algebra expressions. In Database Management System, DBMS. Relational algebra is a set of operations used to retrieve data from relations, tables. Evaluation of relational algebra expressions means the process of executing these operations efficiently to get the required result from the database. What does evaluation mean? When a user writes a query in SQL, the DBMS converts it into relational algebra expressions. These expressions are then evaluated step by step by the DBMS to produce the final result. The main goal of evaluation is to get correct results using minimum time, memory, and disk access. Basic relational algebra operations. Some common operations are selection, sigma selects rows. Projection, pi selects columns. Union, set difference. Cartesian product, times. Join. Steps in evaluation of relational algebra expressions. 1. Expression tree formation. The relational algebra expression is represented as a tree structure. Leaf nodes base relations, tables. Internal nodes operations, sigma, pi. This helps DBMS understand order of execution. 2. Choosing evaluation strategy. DBMS decides which operation to perform first, whether to use indexes, which join method to apply. The idea is to reduce intermediate results. 3. Reducing intermediate relations. Operations like selection and projection are applied as early as possible to reduce the number of tuples, rows, and attributes, columns. Example for easy understanding. Consider two tables. Student, roll no, name, depth. Marks, roll no, subject, marks. Query. Find names of students from CSE who scored above 80. Relational algebra expression. Pi name, sigma depth is equal to CSE marks 80, student marks. Evaluation steps. 1. Select students from CSE. 2. Select marks 80. 3. Join student and marks using roll no. 4. Project only the name. By applying selection early, DBMS avoids unnecessary data processing. Importance of evaluation. Improves query performance. Saves disk space and time. Reduces CPU and memory usage. Helps DBMS handle large databases efficiently. Easy to remember. Select early, project early, join wisely. Conclusion. Evaluation of relational algebra expressions is a core process in DBMS that converts logical queries into efficient execution steps. By choosing the right order of operations and reducing intermediate data, the DBMS ensures fast and accurate query results. This makes databases powerful, scalable, and user-friendly. Next important long question is 2. Query equivalence. In database management systems, DBMS, query equivalence means that two different queries are considered equivalent if they produce the same result for every possible database state, even though they may be written differently. Simply put, different queries, same output is equal to query equivalence. Why is query equivalence important? Query equivalence is the foundation of query optimization. The DBMS uses this concept to rewrite a query into a more efficient form without changing its result. Goal: same answer, less time, less memory, fewer disk accesses. Basic rules of query equivalence. DBMS follows some algebraic rules to transform queries. 1. Commutative property. Order of operations does not matter. RS is equal to SR. RS is equal to SR. 2. Associative property. Grouping of operations does not affect result. RS T is equal to R, ST. 3. Selection rule. Selections can be broken or reordered. Sigma, sigma, R is equal to sigma, sigma, R. Sigma, C1, C2, R is equal to sigma C1, sigma C2, R. 4. Projection rule. Extra attributes can be removed early. Pi A, B, R is equal to pi A, R. 5. Selection push down. Selections should be applied as early as possible. Sigma C, RS is equal to sigma C, RS if condition uses only R. Example for easy understanding. Tables. Employee, EMPID, name, debt, salary. Department, debt, manager. Query. Find names of employees working in HR with salary 40,000. Query 1. Pi name, sigma debt is equal to HR salary 40,000, employee department. Query 2. Optimized but equivalent. Pi name, sigma debt is equal to HR salary 40,000, employee department. Both queries give the same result. Second query is faster because filtering is done early. Thus, they are query equivalent. Role of query equivalence in optimization. Reduces size of intermediate results. Improves execution speed. Helps DBMS choose the best query plan. Ensures correctness is not affected. Easy to remember. Change the query, not the answer. Conclusion. Query equivalence allows DBMS to transform a query into multiple equivalent forms and select the most efficient one. It ensures that performance is improved without changing the final output, making it a key concept in query processing and optimization. Next important long question is 3. Join strategies. In database management system, DBMS, a join is used to combine rows from two or more tables based on a related column. Since joins are costly operations, DBMS uses different join strategies to perform them efficiently. Choosing the right join strategy helps reduce time, memory, and disk usage. Join strategy is equal to method used to perform join efficiently. Why join strategies are needed? Tables may be very large. Data is stored on disk. Wrong join method can make queries very slow. So DBMS selects a suitable join strategy based on size of tables, availability of indexes, memory available. Important join strategies. 1. Nested loop join. This is the simplest join method. How it works. For each row in the first table, DBMS checks all rows in the second table. Example. EMP debt. For each employee, DBMS searches matching department. Easy to implement. Very slow for large tables. 2. Block nested loop join. An improvement over nested loop join. How it works. A block of rows from one table is loaded into memory. It is compared with rows of the second table. Fewer disk accesses. Faster than simple nested loop. 3. Sort merge join. Used when tables are already sorted or can be sorted. How it works. Sort both tables on join attribute. Merge matching rows. Example. Join student and marks on roll no. Efficient for large sorted tables. Sorting takes time if data is unsorted. 4. Hash join. Very fast and commonly used. How it works. A hash table is created on join attribute of smaller table. Matching rows are found using hash function. Best for large tables. Very fast. Not suitable if memory is limited. 5. Index nested loop join. Uses an index on join column. How it works. For each row in one table, DBMS uses index to quickly find matching rows in another table. Very fast when index exists. Index must be available. Example for easy understanding. Tables. Student, roll no, name. Marks, roll no, marks. To find student names with marks. Hash join is fastest if tables are large. Index join works best if marks has index on roll no. Easy to remember. Loop block sort hash index. Conclusion. Join strategies are essential for efficient query processing in DBMS. By choosing the right join method, the DBMS can drastically reduce query execution time and improve overall database performance. Next important long question is 4. Write about query optimization algorithms. Query optimization algorithms. In a database management system, DBMS, query optimization algorithms are used to find the most efficient way to execute a query. A single SQL query can be executed in many different ways, but always give the same result. The job of the optimizer is to choose the plan that uses minimum time, memory, and disk access. Simple idea. Best plan plus same result is equal to query optimization. Why query optimization is needed? Databases contain huge amounts of data. Disk access is slow and costly. Poor execution plans make queries very slow. So DBMS uses optimization algorithms to reduce execution time, reduce intermediate data, improve system performance. Main types of query optimization algorithms. 1. Heuristic, rule-based optimization. This method uses rules of relational algebra to improve queries. Common rules. Perform selection early. Perform projection early. Replace Cartesian product with join. Reorder joins for efficiency. Example. Instead of joining full tables first, DBMS filters rows first, reducing data size. Fast. Simple. Does not consider actual data size. 2. Cost-based optimization. This is the most powerful and widely used approach. How it works. DBMS generates many possible query plans. Calculates cost of each plan, CPU, I/O, memory. Chooses the least cost plan. Costs are calculated using number of rows, size of tables, index availability. Example. If table A is small and table B is large, optimizer chooses hash join instead of nested loop join. Highly efficient. Uses statistics. Slightly complex. 3. Dynamic programming approach. Used mainly in join optimization. How it works. Finds best way to join two tables. Then builds best plan for 3 tables. Continues step by step. Gives optimal join order. Cost increases with many tables. 4. Greedy optimization algorithm. This method chooses the best option at each step. How it works. Selects the cheapest join first. Continues with remaining relations. Faster than full search. May not give global best plan. Example for easy understanding. Query. Find students from CSE department who scored above 80. Optimizer. 1. Applies selection on department and marks first. 2. Reduces rows. 3. Applies join. 4. Projects required columns. Result: fast execution with same output. Easy to remember. Rules first, cost next, best plan wins. Conclusion. Query optimization algorithms help DBMS execute queries efficiently without changing results. By using heuristic rules, cost estimation, and smart join ordering, DBMS ensures fast query performance even with large databases, making optimization a core part of DBMS. Next important long question is 5. Explain indices. In Database Management System, DBMS, an index is a special data structure used to speed up data retrieval from a table. Just like an index in a book helps you quickly find a topic, a database index helps the DBMS find records faster without scanning the entire table. Index is equal to shortcut to data. Why indices are needed? Tables may contain lakhs or crores of records. Searching row by row is slow. Index reduces disk access and search time. With an index, DBMS can directly reach the required data. How indexing works. An index stores search key, column value, pointer to the actual record. When a query is executed, DBMS 1. Searches the index. 2. Finds the address of the record. 3. Retrieves data quickly. Types of indices. 1. Primary index. Created on primary key. Data is stored in sorted order. Example. Roll no in student table. 2. Secondary index. Created on non-key attribute. Multiple records can have same value. Example. Index on depth in employee table. 3. Clustered index. Physically sorts table records. Only one clustered index per table. 4. Non-clustered index. Logical ordering. Table data remains unchanged. Multiple non-clustered indexes possible. 5. Dense and sparse index. Dense index, index entry for every record. Sparse index, index entry for some records only. Example for easy understanding. Table. Student, roll no, name, depth. Query. Select asterisk from student where roll no is equal to 105. Without index. DBMS scans all records, slow. With index on roll no. DBMS jumps directly to roll number 105, fast. Advantages of indices. Faster search and retrieval. Efficient query execution. Reduces disk I/O. Disadvantages of indices. Extra storage space. Slower insert, update, delete operations. Easy to remember. Index speeds search, but slows change. Conclusion. Indices are essential tools in DBMS that improve query performance by allowing quick access to data. When used properly, they greatly enhance database efficiency, especially in large databases, making them a key part of query optimization and storage strategies. Next important long question is 6. B-trees. In Database Management System, DBMS, A B-tree, balanced tree, is a self-balancing index data structure used to store and retrieve data efficiently. It is specially designed for large databases stored on disk, where reading data is slow and expensive. Simple idea. B-tree is equal to balanced index that keeps search fast. Why B-trees are used? Databases store huge amounts of data. Disk access is slow. Simple trees become unbalanced. B-trees ensure fast search, fast insertion, fast deletion, always balanced structure. Important properties of B-trees. 1. Balanced tree. All leaf nodes are at the same level. Search time is always predictable. 2. Multiple keys per node. Each node can store more than one key. Reduces tree height and disk accesses. 3. Sorted order. Keys inside a node are stored in sorted order. 4. Automatic rebalancing. Tree automatically adjusts during insert and delete. How B-tree works? Simple explanation. When data is inserted, if a node becomes full, it is split. Middle key moves up. Tree remains balanced. When data is deleted, nodes borrow or merge keys. Balance is maintained. Example for easy understanding. Suppose we create a B-tree index on roll no in a student table. Roll numbers inserted 10, 20, 30, 40, 50, 60. Instead of forming a long chain, B-tree stores multiple roll numbers in one node. Tree height remains small. Search takes only 2 to 3 disk reads. So, searching roll no is equal to 40 becomes very fast. Advantages of B-trees. Faster searching. Efficient range queries. Less disk I/O. Supports insert, delete, update efficiently. Where B-trees are used. Indexing in DBMS. File systems. Large databases, Oracle, MySQL, SQL Server. B-tree versus binary tree, quick view. Feature binary tree B-tree. Balance may become unbalanced, always balanced. Keys per node 1 multiple. Disk access high-low. Easy to remember. Balanced plus multiple keys is equal to fast access. Conclusion. B-trees are powerful indexing structures in DBMS that keep data sorted, balanced, and quickly accessible. By reducing disk accesses and maintaining balance automatically, B-trees play a critical role in query optimization and efficient storage management. Next important long question is 7. Explain hashing. In database management system, DBMS, hashing is a technique used to quickly locate records in a database by using a hash function. Instead of searching record by record, hashing directly tells the DBMS where the data is stored. Simple idea. Hashing is equal to direct access to data. What is hashing? Hashing uses a hash function to convert a search key into a hash value, which represents the address, bucket, where the record is stored. Hash function. A mathematical function that maps a key to a storage location. Why hashing is used? Very fast data access. No need to scan whole table. Ideal for equality searches, happy smiley. Example for easy understanding. Suppose we have a student table and want to store records using roll no. Hash function. H roll no is equal to roll no %10. If roll no is equal to 123, H 123 is equal to 3. So, record is stored in bucket 3. When searching roll no is equal to 123, DBMS directly goes to bucket 3, making retrieval very fast. Types of hashing. 1. Static hashing. Fixed number of buckets. Hash function does not change. Simple. Problem of overflow when data grows. 2. Dynamic hashing. Buckets grow or shrink dynamically. Hash function adjusts automatically. Handles large databases efficiently. Less overflow. Examples. Extendable hashing. Linear hashing. Hashing with collisions. Sometimes two keys produce the same hash value. This is called a collision. Collision handling methods. Chaining, store multiple records in same bucket using linked list. Open addressing, find another empty bucket. Advantages of hashing. Very fast search. Efficient for large databases. Simple structure. Limitations of hashing. Not suitable for range queries. Collisions reduce performance. Ordering of data is not maintained. Where hashing is used. Database indexing. File organization. Hash joins in query processing. Easy to remember. Hash address direct access. Conclusion. Hashing is a powerful technique in DBMS that provides fast and direct access to data. By using hash functions and efficient collision handling, hashing greatly improves query performance, especially for exact match searches, making it an important part of database storage and retrieval systems.